As you come in this way, it is continuous because it's nice and smooth till you get to 1, right? But if you try and go to the right of 1, it's no good, right? It jumps. But to the left of 1, it's okay. So this would be called left continuous at 1. So if you're standing at this point, 1, right there, and you look to the left of it, your graph is nice and smooth. If you look to the right, it's no good. You have to jump. So that's why you include the bracket on the -1, because it's left continuous there. Now, where does the graph pick up and start acting good again? Union from 1 parenthesis to 3, bracket or parenthesis? Parenthesis, because it's undefined there. Union 3 to infinity. So on all of those intervals, our function is continuous. Questions? It's an infinite discontinuity, yep. And all that you need for that is for your function to be heading off to infinity at that point. All right, this next example is kind of neat. Find A and B. Well, what type of function is this? When you have a function that's like different piecewise, right? It says we need to try and find an A and a B. That means 2 numbers. So A and B right here, those are constants. Give me the 2 numbers so that when you figure those numbers out, replace the A here with whatever you figure it out to be, and the B here, and that B here and the A here, that when you do all that, this entire function is continuous everywhere, from -infinity to infinity. So I'll give you a second to jot this down. Everyone has their notes, right? You should have them. Where am I? I want to refer real quick in the notes to, ow. I'm sorry, the notes were out of order. 1.6 was before 1.5. Did y'all notice? That's because last semester I did 1.6 before 1.5. I forgot to change it. Continuity, it's 1.5.2. Wait, no, 1. 1.5.1 is the definition of continuity. Or just because I'm going to refer to that in a second. So, everyone have this written down? Okay. Let's just look at these pieces. This first piece right here, x squared minus 4. If I graph that, it looks like a what? It's a parabola, okay? It's a parabola. It opens up, doesn't it? It's moved down 4. But it's only drawn to the left of 1, isn't it? And then the second piece is what? What type of function is that? Ax squared plus 4b. It's a parabola. Well, we don't know. Yeah, we don't know anything about a and b, do we? So I can't tell you right now if that opens up or down. But I can tell you it's a parabola, right? Because it'll be x squared, some number in front of x squared, and then some number added to it. So that's a parabola also. And then what's the last one? What type of function is this? It's a line. But it's only drawn to the right of 4. So I'm curious how many of you really understand what's going on here. So I have a picture that will hopefully help us. All right. What I've done is I've written a little code here to plot the first function in blue, that's the x squared plus 4, or minus 4, right? Was it minus 4? Okay. There's x squared minus 4, and notice it's only drawn to the left of 1, right? And it has an open circle here. Why does it have an open circle? Go back up to the definition here. It's x squared minus 4 if x is less than 1, right? So at 1, it's not this function, right? Now, in between 1 and 4, it's this parabola, this red one, right? But we don't know what A and B are, right? So this little thing allows me to slide around and change values of A and B. So I can change what that red parabola looks like. See, so I'm changing A, and it's changing that middle parabola, isn't it? But it's also changing this black piece. What's that black piece? That's the line. It's changing the line because, look, the A here affects that line. So if I change A in this second one, it's going to change the third one. If I change B, it's going to change them both also, right? So now here's my little slider for B. If I change B, it starts moving them around. What am I trying to find? I mean, like, tell me kind of in words what I'm trying to figure out here. Yeah, but say it again. Yeah, I'm trying to connect them all. I'm trying to find an A and a B, which makes it where I can draw this without picking up my pencil. So it's continuous. I mean, this blue one's continuous, isn't it? Until I get here, and then I have a jump discontinuity. And this red one's continuous by itself, but then I have a jump discontinuity. There might be an A and a B that I can get to kind of, I don't know, maybe there's some place in here. Shit, I don't know if I'm going to be able to find it. Maybe I can. See, I can't guess. It's too hard to guess. Oh, wait, hold on, I'm getting close. Oh, shit. Every time I try and move one, it messes the other one up. You see that? But is there a solution? Well, if I click this snap, it takes us to the solution. Negative 3/16 for A and negative 45/64 for B. That's the solution. Now, how are we going to find that? Right? That's the question. But I want you to see in pictures what we're trying to do. Does everyone agree that picture is continuous? Okay. So let's get back to the problem. The key to getting started here is to understand that each of these three pieces by themselves are all continuous because they're all polynomials. And if you look at note, where is it? 1.5.9. It says functions which are continuous. All polynomials functions are continuous on negative infinity to infinity, 1.5.9. All polynomial functions. And so each of these three pieces are all polynomials, aren't they? So I know by themselves they're continuous. The problem, the only problem I have is where they come together, right? Where they join. So what I need in order to start this problem, I need f, this function, to be continuous where? I mean, I know I need it everywhere, but where are the only places I'm really concerned about? Where the jumps are, right? At 1 and at 4, right? So I need this f to be continuous at x equals 1, and I need it to be continuous at x equals 4. Does everyone understand that reasoning? It's coming from where our piecewise function splits. This is everything to the left of 1, everything between 1 and 4, everything to the right of 4. Follow? All right, so now using the definition of what it means to be continuous, let's try and figure this out. To be continuous, I'm just going to put cont dot at x equals 1 means, by the definition of continuity, so I'm referring to 1.5.1, the definition of continuity says a function is said to be continuous at x equals a if the limit as x approaches a, but what's a here? What is it? Where do I want it to be continuous? At 1? So I need the limit as I approach 1 of the function to be equal to what? F of A. What's A, though? Oh, don't confuse it with the A in the problem. Yeah, it's 1. I can see where that could be confusing. This is big time. You got to understand that. All I'm doing right there is writing down what it means for a function to be continuous at a point x equals 1. So let's work with this equation. Let's work with left side and right side. So let's talk about the left side a little bit. Well, you know what? Let's do the right side. The right side's easier. What's f of 1, everyone? So go look at your function and try and plug 1 in. So which of these pieces would you plug into? The first, second, or third piece? If I'm trying to plug 1 in for x. Well, I use this first one if the x I'm plugging in is smaller than 1. What am I trying to plug in? 1. So I don't use this piece because 1 isn't smaller than 1. The middle one, right? So if x is 1 right there in the middle, then 1 is definitely bigger than or equal to 1, isn't it? So I would use this middle piece. So go into the middle piece and replace x with 1 and tell me what you would get. A times 1, which is just A, plus 4b. Yes? So this right side of this equation was A plus 4b. Now let's go to the other side, the left side. Tell me a little bit about this. It's a limit, right? Does the limit mean that I want to plug in 1? It means I want to get close to 1, right? So if I go back up to my function, which of these pieces do I want to use? The top one, or the middle one, or the last one? If I want to be close to 1 but not 1. The top one. Because in the top one, if I plug in a number here, I can get really close to 1 without being 1, like 0.999. Right? So plug in, just substitute 1 into this now, because it's a limit, right? So watch, I'm actually going to write this down. I'm actually doing the limit as x approaches 1 of the top function, which was x squared minus 4. And what is that limit? That's a direct substitution limit, isn't it? What do you get when you plug 1 into that? -3. So the left side of this equation is -3. The right side is A plus 4b. So what I've created here is an equation. The problem with that equation is that I cannot solve it. Why? 2 variables. 1 equation, 2 variables. You cannot solve and give me an answer like you know, A equals 2. You can't, because you don't know what B is. So where do you think we're going to get the other information from? What's the other thing I'm supposed to be able to determine here? Yep. Hold on, I forgot how to go full screen here. F11. All right, there we go. So I also needed this to be continuous at 4. Does everyone see that I didn't have enough information by just looking at the continuity at 1? I need now to look at the continuity at 4 also. What does it mean? It means that I need the limit as x approaches what this time? 4 of the function f of x to be equal to f of 4.